In this video, we'll discuss the area and circumference of circles. Now first, let's define some of the parts of a circle. First, we have the diameter. The diameter is the distance from one side of the circle to the other side, and it must go through the center of the circle. Whereas the radius goes from the center of the circle to any part of the edge of the circle. The circumference represents the length of the edge around the circle, and if we think about other polygons, this would be equivalent to the perimeter of the circle. And lastly, we have the area of the circle. That's the space inside the circle. Now, when we calculate the circumference, we have two ways we can think about it. We can either say it's the diameter times pi, or we can look at it as 2 times the radius times pi, because the diameter is twice the length of the radius. You're going to be asked to both calculate the circumference exact as well as approximately. And anytime that you need to calculate an approximate value for the circumference, use the value of 3.1415 for pi. That'll give you a more accurate estimate versus using just 3.14, which is commonly used. So say we want to compare two pizzas, and we want to know how many more inches of crust is around a 14-inch pizza compared to a 12-inch pizza. And we're going to provide both the exact amount and the approximate amount to the nearest tenth. So let's look at each pizza separately. With the 14-inch pizza, we're saying how many more inches of crust is around it. So we're looking at this case around the edge of the circle, which would be the circumference, which means we also need the diameter. In this case, since it's a 14-inch pizza, the diameter is 14 inches. So we can use our circumference where we have the diameter already, and that will be 14 inches times pi, which would be 14 pi inches, because pi is a number. So we'll write that, then the unit of inches. That's the exact amount. The approximate amount, if we use the 3.1415, would be about 43 and 981 thousandths of inches. Now let's look at the 12-inch pizza. Again, we're going around the circle, which means we're looking at the circumference. So we're going to start with the diameter and then multiply that by pi. That would be 12 pi inches as the exact amount. And approximately, that would give us 37 and 698 thousandths inches. So if we want to know the difference, and we want to do the exact difference, we would start by doing 14 pi inches minus 12 pi inches, which would mean that the 14-inch pie has 2 pi inches more crust than the 12-inch pizza. And approximately, that would be 6 3/10 inches. And if you took these two approximations, you would get that same value if you subtracted them. Now we can also do the same thing with the area. The area is the radius squared times pi. So if we have the diameter, we just need to remember to divide it by 2 to get the radius. And again, we're going to use 3.1415 whenever we need to approximate for pi. So we talked about how much more crust is on a 14-inch pizza. Well, how much bigger is a 14-inch pizza? Here we'd be thinking about the area of that pizza. So we're going to start and say the area is all that part that's inside the pizza, and we know it's a 14-inch diameter. That means the radius has to be 7 inches. So we do 7 inches squared times pi. And this is what helps me recognize that my units are squared. So this becomes 49 pi square inches. That's the exact amount. And if I want the approximate, it would be 153 and 9,335 10,000ths square inches. Now I can do the same thing for the 12-inch pizza. Again, it's all the part that's inside there, and it's a 12-inch diameter, which means the radius is 6 inches. So if I take the area of this pizza, it'd be 6 inches, that whole quantity squared, times pi. There would give me 36 pi inches for the exact amount, and approximately 113 and 94 thousandths square inches. So if I want to know the difference in area, I would subtract the exact amounts. 49 pi square inches minus 36 pi square inches is 13 pi square inches. If I want the approximate, that would be approximately 40 and 8/10 square inches. And that's what I would get if I took my approximate values here, or if I said 13 times 3.1415 and rounded to the 10th. Now I can take the same problem and extend it to understand what if we look at it from the number of slices of pizza that people get. Say a 12-inch pizza normally serves 6 people. That's 1 slice per person. If we want to keep the same size per slice, how many people can a 14-inch pizza serve? And this is often what pizza places are actually doing. So when they say same size per slice, what we're talking about is keeping the area the same, whether it's a 12-inch pizza or a 14-inch pizza for each of those slices. So say we have our 12-inch pizza here. We know from before that the area of that 12-inch pizza was 36 pi square inches. Now we're talking about serving 6 people. That means we're going to take and split it into 6 individual sections, and they all will have the same amount. So in essence, we're going to take that 36 pi square inches and divide it by 6 to say that's the area per each slice. So that's 6 pi square inches, and that's what we're going to use then to help us think about the area for each pie piece in the 14-inch pizza. So we know that the 14-inch pizza had 49 square inches. So if we want to know the number of slices, we would take that area and divide it by the area per each slice. It's another way to then turn this problem. And that would be 49 pi square inches divided by 6 pi square inches per slice. And you see what happens there is my square inches simplify, leave me just with my per slice, and following my division of fractions means to multiply by the reciprocal. That unit of slices ends up in my numerator, exactly where I'd want it to know the number of slices. When I divide 49 pi by 6 pi, I get 8 1/6 slices. What that means is that we can cut this pizza into approximately 8 slices and serve 8 people. Now we can also take the area of a circle and use the moving and additivity principles to combine it with other shapes. For example, say that we have this unique shape here, and we want to find and determine the area rounded to the nearest tenth. So I would say let's use that additivity principle to separate this into separate shapes that I do recognize. If I make a rectangle, what I end up seeing here is I have a semicircle and another semicircle, and I can use those 3 shapes then to help me out. So I have the area of this rectangle, the area of this semicircle, and the area of this semicircle. Let's find them one at a time. So I know that the area of the rectangle is length times width. So that would be 12 centimeters times 8 centimeters, which is 96 square centimeters. So there's one area down. Now let's find the area of the semicircle. And the area of the semicircle with an 8 centimeter diameter means I'm going to use a radius of 4. And since it's a semicircle, that's 1/2 of the pi r squared that you think of. It's half of the circle. So 4 centimeters quantity squared will give me 16 pi square centimeters. Then I'm going to divide by the 2, which means that's 8 pi square centimeters. That comes out to approximately 25 132 thousandths square centimeters. There's 2 shapes down. Let's find that bottom half semicircle as well. And again, that's a semicircle with 12 centimeters as a diameter, so our radius would be 6 centimeters. So using that half of the area, so that's 1/2 of 6 centimeters quantity squared times pi, so we're doing half of 36 pi square centimeters, which is 18 pi square centimeters. And if you approximate that, that's 56 547 thousandths square centimeters. Now I have my 3 areas. If I want the total area, I will add those 3 areas together, and that will give me approximately 177 679 thousandths square centimeters. But again, we're rounding to the 10th, so this would be approximately 177 7/10 square centimeters for this shape.